Hello everyone and welcome to today's video. So today's video will be about how you can increase revenues or profits in your business or for your business using the goal seeker and solver function in Excel. So today we will be discussing an application of goal seeker and solver function so that you can diversify your efforts very efficiently and increase profits and revenues in your businesses. So these goal seeker and solver function can be extended to further more applications as well. So you can play around with the Excel sheet that I have placed in the description below to solve your own customized scenarios. I hope you would have liked the video by now. Please subscribe to our channel as well for more such videos. With that said, let's get to the video. So to illustrate the working of GoalSeek, I have taken a very simple example of a shopkeeper who is trying to sell particular item and the data around that item is shown in this table. So let us suppose that item cost the shopkeeper 10 rupees and he is able to sell it at 12 rupees, making a 2 rupees profit on one unit of that item, and there is a fixed cost associated with the delivery or manufacturing of that item. So this is 12,000 rupees, basically setting up some shop or something. So now using the goal seek function, we will be able to answer these two questions. So the first question states how much units should be sold to break even profits and losses. Basically to create a profit of 0 rupees, that is to break even, how much units should he sell? So we can achieve this using the hidden trial method also. So I can type the unit sold on my own to generate the profit figure, but to do this one efficiently we would be using the goal seek function. So to use the goal seek function onto this table, I'll simply go to data, go to what if analysis and go to goal seek, and then set the cell value. So I want the total profit to be 0 to answer the first question that I have. So I will set the value in this cell to 0 so that my profit and losses are broke even, and then it wants us to specify the cell that you want to change. So I simply want to change the unit sold cell. So now what Excel will do is it will optimize for that number under the unit sold column to give me zero profits or zero losses, that is the break even number of units sold. So I will simply press OK, and now it gives me the answer that by selling 6,000 units I will be able to break even or create zero profits and zero losses on my investment. So now let's move on to answer the second question using goal seek function, that is how much units will the shopkeeper need to sell in order to earn a profit of 5 lakh rupees. So to do that, I'll simply again go to what if analysis and go to goal seek, and instead of setting this column to 0, this time I will set up this column to 5 lakh rupees. Once I'm done with that, I want the changing cell to be cell F8 and I'll press OK. So now in order to earn 5 lakh rupees from this business, you need to sell 2 lakh 56,000 worth of units. So now we will move on to discuss how a solver is able to achieve our objective, that is it is able to minimize or maximize a particular value given the constraints that we have. So I will be illustrating the functioning of solver by taking a more complex example. First of all, you need to enable solver on your Excel sheet. So if you're not able to see solver under the data tab, you need to simply go to file, go to more, and go to the options tab, and then under the options tab you should go to add-ins, and under the add-ins you will see the solver under inactive application add-ins. Since I have already added in the solver in my Excel sheet, it is showing up as active application add-ins. So you have to simply just click on it and go and press the go button and press OK. Once you're done with that, you will be able to see the solver function under the data ribbon in your Excel sheet. So let us first understand the problem statement that we have at hand. So for example, there is a shopkeeper who is selling multiple items in the region where he is operating. So there is a demand for certain items in that region. So the demand for every item is different in that particular region, and there is an average profit per item. So some items are more profitable than the other and vice versa. And in addition to that, we have a constraint of staff capacity. So the staff which the business had can serve only 20,000 items, whatever the demand may be. To work in those constraints, we need to calculate the net profit number, that is the number of units that needed to be sold for each category to break even profits or to earn the given amount of profit. So we can play around with this sheet and basically evaluate as to how much effort will it take with the given resources to earn a particular amount of profit. So we have the fixed cost also, which is being catered to calculate the net profit numbers. So net profit is basically the sum of all these numbers minus the fixed cost that we have. So fixed cost can be anything in a business related to delivery or manufacturing. So to evaluate the answer to first question using solver, what we will do is we'll simply go to data and go to solver, and then it will give us a prompt which will prompt us to enter certain parameters that the solver requires to function. So our first question was that how much units should be sold under each category to break even. So basically break even refers to making the profit to zero. So basically to have zero losses and zero profits, what should be the units sold under each item type. So to do that, I will simply set the objective that I want this cell to show a value of 0. So I can do that using this by changing the variable cells. So what variable cells can I change, which is the unit sold? So I am mentioning that range. Once I'm done with that, I will now give the constraints to the solver parameters. So the constraints are, the first constraint is that I want all the units sold to be in integer numbers, and I don't want the partial units sold. So I will select integer and press OK. So I'm done with that constraint. Then I will add another constraint, which is the units sold should always be less than or equal to the demand that I have in that area. So I don't want to exceed the demand for a particular item type so that my stock does not go unsold. So I will add that constraint as well. And once I'm done with that constraint, I will be adding another constraint, which is that the sum of the total sold items should not exceed the staff capacity. That is the capacity at which the staff can serve the items. So that is 20,000. So the total units sold should not exceed 20,000 with the given resources. Once I'm done with all the constraints I have mentioned, I will simply click this make unconstrained variables non-negative. So I will be clicking onto this for most of the scenarios since I don't want negative values in my solver. And post that we have the solving method. So there are three methods under this. So the three solving method that we have are GRG nonlinear, simplex linear programming, and evolutionary. So GRG basically stands for reduced gradient. So this solver method is basically used when your data is non-linear, and it is used to calculate local maxima, local minima inside your data. So for example, if you are aware of the concept of local maxima or global maxima. So what it does is it basically finds out the local maxima and stops at that point, and in some instances it might not be able to reach to global maximum. So in order to accommodate the GRG non-linear with that global maxima value, you can simply go to options and go to GRG non-linear and use multi-start. So in this way, it will be able to give you the global maxima or the global minima of the function that you're trying to apply. So since this would take more computation time, I am unchecking this as of now. So the second method to this is simplex linear programming, which is used when your data is linear in nature. The third method which the solver can use is the evolutionary method. It solves for global maxima or global minima, which is why it takes more computation time than the GRG non-linear data. So for most of the times, GRG non-linear is highly efficient in terms of computational time and in terms of calculations as well. So we majorly use GRG non-linear with the solver. So once I'm done with all the parameters in the solver prompt, I will simply click on solve to get the answer from the solver from the first question. So as per the answer provided by the solver, it has given us the unit sold for every item, which will lead us to break even in our scenario, which is to cover up the fixed cost that we had in our problem. So for the items which are highly profitable, it is giving us more units to create. And for items which are less profitable, like the chocolates, it is giving us less units to be sold. So basically, and this range is under the staff capacity. So it caters to all the constraints and gives us the objective that we want to achieve. Similarly, we can answer the second question on our radar, which is as to how much units should be sold under each category to earn maximum profits. So with the staff capacity of 20,000 and to earn the maximum profits, like the best profit that we can earn in this scenario. So what would be that profit? So to do that, I can simply go to solver, and instead of specifying the value of 0, I will just select max, and keeping all the constraints as they were and the solving method as it was, I will simply press the solve button, and now it has given me the answers as to maximum profit that I can make using the given constraint. I will select the keep solver solution and press OK. And so you will be able to see that it optimizes chocolates to 1500 since the demand is 10,000, but the average profit is very less, comparatively very less compared to other items. So since the demand is very close to the capacity that I have mentioned in this problem, which is why it is just optimizing for chocolates, and for all other items it is just giving me the demand number. So to adjust for that, I will simply reduce the staff capacity. So let's say I reduce the staff capacity to 10,000, and once I'm done with that, I can play with it more, or I can choose to run the solver again. And once I will run the solver again, it gives me a new solution. So as per the new solution, since our staff capacity is now reduced to half, it is now focusing more on items which have larger profits. So for example, for gift hampers which has 100 rupees, and for main course which has 150 rupees, it is recommending us to meet the demands. And for low profit items, it is recommending to not sell those items, since we have the staff capacity to 10,000 only. So you can play around with the sheet as per your business scenario, and basically calculate the maximum values of net profit. And you can use this for other applications as well, where you will be calculating global minimas or local minimas. So you can basically choose to minimize or maximize a certain parameter using solver. That brings us to the end of today's episode. Thank you for watching, and I will see you soon in the next video.